So this is hotspot analysis. To analyze the hotspot of disease outbreak, you have to have this data, this Oromia town point data and Oromia districts, right? In the Oromia town point data, we have this is outbreak data. You can see on the attribute table, open it, and here we have a lot of data. Basically, this table is data rich table. So here is, we have, this is outbreak of each worada, cattle population of each worada, animal shelter in each worada, and veterinary hospitals of each worada. So based on this data, especially this is outbreak or this is occurrence of each worada of Oromia, you can analyze, or you can generate and analyze the disease occurrence or outbreak hotspot areas of Oromia region. Okay, to do so, you have to go to here, search, and find the kernel density. The module or the tool that enables us to calculate this hotspot is the kernel density. In order to do that, please open it, double click and open, and then our input is the town. Okay, and then the population field should be the disease outbreak or disease occurrence in Oromia districts, and then you have to save your output here. And output here we do have the disease. This is outbreak. This is occurrence, or you can say outbreak. Okay, and then okay, it is long name. Simply we can say this is out. Yeah, so this is cell size should be like this. If you need, you can correct here and then make it okay or run it. Now it is processing. Okay, you see, this is outbreak hotspot map. You can make this hollow to see the lower layer, or what is there in the lower layer. You see, this tells us this is outbreak in Oromia district or others. For example, you see here in the central part, here in the south central part, sorry, southern central part, and here in the western central and the central Oromia, there is high density of this outbreak, or that we call it hotspot. Okay, but one thing you have to be careful is that you see here this not calculated here. The kernel density doesn't calculate in this part and in this part, and in this part, especially in the peripheral bound areas of the districts of Oromia. So to fix this problem, go to here, the geoprocessing, and then environmental setting. Last time I showed you this one. This is very important and a really basic thing, and you have to set extent as Oromia does. Okay, and snap raster, we don't have snap raster, and go to here, the raster analysis, and here the mask should be the Oromia Oradas, right? Now make it okay, and then go to here, kernel density, and run it. And here they input the town, and then your z value or field is this is outbreak, and then here your output is this is out, and the second output. Okay, now you will see what will happen. Now we have this one, and then let us start with the first one. Okay, now here this is based on what? Based on the shapefile of Oromia district. So this one is the way how to calculate our hotspot area or disease prevalence or outbreak area. So you can also change the color. This is the default color. You can change the color to your own preference or interest. Okay, go to here symbology. Here we do have this color ramp, and then you can use any of these options, especially let us use this one. It should be like this. Okay, so this okay, here we do have two red colors. Let us change it in order to avoid any confusion. Okay, let us use this one. Yeah, this one. Okay, this green one, this one, the dark green tells us no, this is outbreak, right? But the red one tells us there is high disease outbreak here. This is the index of disease outbreak or the density of disease outbreak. So in such a way, you can analyze the disease outbreak in Oromia region, right? So this is how to analyze disease outbreak in a given region or in a given geographical location. I hope you are clear with this one. Let us proceed to the next one. So the next step is to classify this into low, medium, and high risk areas, right? Already here we have basically this one is low, this one is medium, this one is high risk area, but instead of that, you can classify this into low, medium, and high risk area. How can we do that? Last time I showed you one more step. Here we can't open the attribute table. In order to open this, we have to what? Reclassify this map. Okay, then we can enter that one. For example, here low, medium, and high risk zones. Okay, to do so, let us reclassify this. You can use reclassify tool. Okay, from spatial analysis toolset, you can open and access this reclassify tool. You can use this tool, right? Now we are gonna to classify this. Go to this classification, and then you can use one of the method. Let us use the default, and class should be 3, right? What? Low, medium, and high risk zones. Excellent. So now we have 3 classes. Don't forget this one, this range. Write down and you will tell me this range. Okay, this from 0 to, write down please, from 0 to 0.002. 0.002. Let us round off it 2. Okay, okay. So here the first old value from 0 up to 0.002, this is new value 1, right? Don't forget this, because after generating this, we are gonna to insert this value, right? So The next range from 0.002 to 0.004, that is new value 2. And the last one is from 0.004 to 0.009, we can round off it, and that is 3, right? So we should be careful because we will insert it, and this one, the first one is this is we'll classify into medium, or sorry, low, medium, and high risk. This is outbreak zones, okay, based on the value. This one, the first one is low risk zone, the second one is medium risk zone, and the third one is that is high risk zone. Okay, now this is output raster. Go to your output here, you can say it, this is underscore risk zones. Okay, here the name, we have to be careful, the name, in simple you can say risk zone in this, like this, and run it. You see, now we have this map, risk map, right? This is outbreak risk map, or animal disease outbreak risk map. We can generate like this, okay? Then you can open it here, okay? You see, nothing is there except the value, new value, and count, right? So let us add field to insert risk zone. Okay, add field. This field should be risk, okay, zone. It should be text because you are gonna to insert like low, medium, and high risk zone. Okay, the next one, add the area of each area in bracket. You can say in kilometer square should be, because if it is a very large area, in kilometer square, and should be in double like this. Okay, this field is enough. Okay, so here we have area in kilometer square, and this one risk zone. Let us edit it, right? Before that, and area percentage as well. You can also insert percentage. That means area percentage. You can use that one, and here it is, right? Area coverage. So now let us gonna to calculate this area. Simply we can calculate area. Go to field calculator, and here, right, in kilometer square, areas in kilometer square is equal to count. Count means what? This number of pixels in that, in a given area, right? In a given risk zone, number of pixels. For example, in the first zone, that means in the low risk zone, we have this number of pixels. For example, 18,000 unit pixels are there. So now we are going to convert that pixel into area in kilometer square. So to do so, here we have to multiply this count by a single cell area. To do so, we have to go to, and we have to see the we have to go to the table of content, and we have to see the pixel size. Go to source here. Let us see the pixel size. You see here the pixel size by this one, really very coarse pixel. So by this, so we have to copy this, and this pixel size and open here this attribute and go to here and calculate that area. This you see here, you can paste this here and multiply, you see, this pixels area and divided by what? 1 million, because it is by what? By kilometer square, right? Here is we have this one by 1 million. If it is 1 in kilometer square, we have to multiply, we have to divide the area by the 1 million factor, and then we can get it the area of each zone. Here is the area. Okay, the percentage, in order to calculate the percentage, go to here statistics and bring this total area. Are you following me, please? This total area, and now go to this percentage, right? Go to here, and then instead of this one, this percentage is equal to this each area, okay? Each area multiplied by what? Multiplied by 100, okay, divided by what? This total. You see here, this is the percentage of each zone. And finally, let us insert this low, medium, you see here, low, medium, and high risk zones. Risk zones, low, medium, and high. Now let us edit. You can use editor now, okay? You can use editor now to edit that one. This one, risk zone, this one is low. Low risk zone, and then medium risk zone, and then this one is high. Even we can say very high if you need. High risk zone. High risk zone, and then you can save it. Stop editing. Save it, right? We have finished now. Risk zone. Okay. So next we can map that one. Go to here. It is 1, 2, 3. Instead of that, you can change it to risk map. Can go to symbology here, classify, go to this okay, go to unique value here, this one, you see here. Now we have this high risk zone, low risk zone, medium risk zone. Instead of green, this one, you can use basically red one because it is risky area, okay? So like this, you can calculate risk map of this is outbreak. That is it. Okay, the next one, we'll see how to calculate animal population. Let us calculate animal population. You can uncheck this one and come to here, or you can uncheck this one. And then go to here, go to property, go to symbology, and then here, categorical, unique value, okay. Here, graduated color, you can use graduated color to map animal population. Okay, Maze, okay, okay. You can first of all, you can join the two maps, right? Right click here, go to join, you see here, join this, choose the field, and this field ID, Romeo town, this field, okay, okay, and then now you can see here the table is big enough, and then now we can access that animal population or cattle population. You understand, guys? Yeah. So now right click on it and go to this again, and now go to here. Now we can get it right. You see, now already it is there. So the cattle population, find that. Here it is, and should be like this. Unique value instead of unique value, we have to have this graduating color. Okay, that is the best way option. And you have to have this the class. If you need the class, you can make it 10, no matter. And then you can map like this. This is animal population in cattle population in Oromia region. So you can map like this and generate the uh, layout map for this. Okay, layout map for this. Okay, next let's see the proximity analysis. Proximity to the infrastructure, especially proximity to veterinary hospitals and animal health centers. So to do so, go to here and access Euclidean distance, that is in a spatial analysis toolset. Okay. Okay. Double click on it, and then here, go to here, and then input this feature, and your output should be proximity. Proximity to what? To veterinary hospital. Okay, veterinary hospital. So here you have output cell size. Already we set the environment, so it can calculate only by the shape file of our marriage. You see, this is proximity to the health center, animal health center in Oromia region, or veterinary hospital. So you can say this is veterinary hospital proximity or proximity analysis to veterinary hospital. It is important to analyze, and especially the disease risk. Okay, this is risk. And the relationship between disease outbreak as well as the health centers. Okay. So in order to determine high risk zone or high risk area in our study area, these are the inputs, right? To analyze where is high risk in terms of different factors, in terms of elevation, population district, animal population or cattle population of each district, and this is outbreak, and proximity to veterinary facility, especially veterinary hospital that we have seen. So the next is how to calculate the hydrological analysis, especially the watershed delineation and the flow direction, right? You can delineate watershed as well as the flow direction. That is pretty simple. To do so, you have to have the digital elevation model. I think last time also we have seen how to do that. Here we have the digital elevation model of Oromia region, but it is a very, very large data. In order to save our time, we have to delineate a watershed, and then we have to see we have to have area of interest. Okay, so to calculate the hydrology component, we have to open a new window and let's have this general and our digital division model. This is our general in order to minimize the space and time to compete our hydrology components. So we are going to calculate or compute some hydrology component in this area. Okay. To do so, we can extract by mask. We can use extract by mask. By mask. Our input is this Romeo, and this the general, and here we can say this is general DM, you can say like that. Okay, we can run it. It is it, so we can uncheck this one. Here we have this simplified general. Okay, let us have study area around here. Before that, let us follow the steps, right? First of all, we have to fill the, okay, there. I told you the fill concept. Fill it. Okay. Let us fill it. Now it is done, right? Because there is no complication and pass issue. So the next one is flow direction. Fill is now the input, and then simply you can say FD flow direction. By the way, this is how to generate water components in order to incorporate in your this outbreak analysis and some important correlations of this outbreak with some watershed components, right? And the next one is flow accumulation, which is a very important part. Our input is flow direction, and here you can say flow accumulation, and okay. You see, now this is flow accumulation, very important one. It tells us the flow accumulation. Let us to full extent, and you see here, look, this tells us the flow accumulation. Now, in order to, delineate watershed, here, this watershed, we have to have the snapper point. To do so, we have to create snapper point in our database. So here, right click in the output. You see here in the output, okay, new, it should be shape file. The name should be, you can say PowerPoint. This PowerPoint, right? In point, and you can have same coordinate reference system with that of your data. And now go to this edit, start editing this PowerPoint. Okay. Now come to here, it is here, and let us have from this area. Okay. Now save this, stop it, and save it. It's here, right? And now let us run this snapper point. Okay, let's run it. Our input is this one. Input raster feature point, PowerPoint, this one. Here it is the PowerPoint field ID, and input accumulation raster. This one is flow accumulation, and our output, this one is snap, and snap for point. Okay, and then convert it to raster. This is snap for point. Yes, it is done. It is here. Snap for point. Now let us, generate watershed. Input flow direction. This is flow direction. Input raster of feature per point. This is snap per point. Okay, should be value. And finally here, watershed. Okay, is processing. Yeah, it is done, right? So now go to your table of content and you can see what is happening there. Table of content. This is the watershed. Give another color here, and here it is. You can make it full extent, and here we do have this watershed. Okay, here we do have this. We can export this one or convert it to shape file. Okay, now let us convert it to shape file. Raster to raster to. Let us raster to vector or raster to. Okay. Instead of, let's say, conversion. Okay. I think now we can access raster to flow, raster to point, raster to polygon. You can run this raster to polygon, and then now we can to convert this into shape file, which is very important. Okay, your watershed. Okay, no watershed. If there is watershed too, it says there is watershed name in the database. You see it is converted, so you can uncheck everything else. Now we have this one, so you can extract this the flow direction and the flow accumulation, and you can generate river, proximity to river, and then you can integrate with your veterinary data. So to do so, let us extract this by mask. By mask. By mask. The first is input raster should be flow accumulation. Okay. This one is the clip feature, and now here you can say flow accumulation underscore area of interest. Okay, the name should be like this, and you can run. Yes, it is done. Flow accumulation. You can allow this to see in it. You see this flow accumulation by the shape file of the study area, and then the next one is flow direction. Input raster, this flow direction FD, clip feature, our watershed study area, and then here FD underscore area of interest. And okay. It is pretty simple. You can do this. As it is done, you can avoid that of the large area. Okay. You can avoid this one. And again, okay. again this one, this general name and general field. Okay, and again this general again, you can avoid it. Now let us come to here. You see, these are some of watershed components: flow direction, flow accumulation, and also you can generate a reverse of that. For example, first of here we have this tools to do so. Let us stream link and stream order. Input stream raster. Okay. Sorry. Okay, let us order stream raster. Okay. Okay, let us link this stream. Our input is flow accumulation. This flow accumulation input flow direction. Here area of interest flow direction. And finally, this is, we can say, stream link. Yes, it is done. And you can see this stream link. Here it is, the stream link, right? Here it is, you can see this. This is a stream link. Stream link. Okay. So next to that, we can generate the stream order. Our input is stream link for this. And here we have flow direction. And then stream, this is stream order. You can say stream order. Strehler stream order, the default. You see, here is the stream order, right? This is very important information. This is the stream order. You can see here. You see the stream order of the study area. Here we have the stream order by order and by color. Okay. Now we can convert this into shape file. You can use this stream to feature. Stream to feature. Let's stream order our input. And here flow direction, of interest. And then here we can say stream. Streams. Okay. Okay. And then okay. You see now we get stream. This one. This is stream. One shape file. You can use this. You see now we generated a river. So you can also calculate the proximity to river in order to overlay with some veterinary hospital, veterinary health center, and disease outbreak points, and to overlay and analyze some disease risk areas. Okay, so you can calculate the distance, the distance of this river. Now our input is streams, output is proximity to river. Prox river distance. We have to manage to reduce the naming because this is sensitive, and everything should be the default. You see, this is distance, Euclidean distance to river. Distance to river. So that enables you to analyze the this is correlation with distance to river, and this is outbreak hotspot area. which in relation to this proximity to river and like that. In order to clip this distance by the shapefile of this, you have to set this in what? In the here, for example, environmental setting. I showed you that one. Go to this extent and then by watershed, you can say watershed 2, where is it? Let us find it. This one. And then go to here, raster analysis, and then the mask. Here it is, right? Watershed 2, and okay. Now we can compete the water the proximity to the river distance in the shapefile in the boundary of our study area or area of interest here like this without any missed area. But in this one we have missed here and here, here and here, especially in the boundaries or borders of the study area. Okay, so we have fixed that by setting in the environmental setting. So now let us calculate it. Our input is the streams, and this output is the proximity to river. Okay, this one, proximity to river. Okay, so okay, and then run it. Yeah, now it is by the shapefile of the river. You see, this is proximity to river shapefile. Okay, so you have this proximity to river data, and then you can integrate with other data like proximity to health center, veterinary health center, and or animal health center, and this is outbreak map, and then finally you can find the suitability area or highly risk area and suitable area for animal production and on. This is all about our today's lesson. Thank you for listening. Have a nice time. So finally, you have to save it here to open for the next time in this output. This is yes, on the output exactly there in our here. This is the first was animal distribution. This one is what you call it, proximity analysis. You can say proximity analysis. Animal proximity analysis. Sorry, kernel density, I think kernel density, and the proximity analysis. Save it, and next time you'll open it.